Today you're going to learn about all the different properties of logs, and I just want to first review right here. If someone asked you what's the log of 4 base 4, now you can obviously type this in your calculator. You can type in log of 4 base 4, and if you do that you're going to get the answer 1. But I want you to learn to rewrite this. How do you rewrite this problem in exponential form? What does it look like? You take the base, which is 4, raise it to this power, and equals 4. Now, what would x have to be to make these two equal to each other? 1. Now, if I gave you anything with the log, if I gave you the log of 5 base 5, the log of 6 base 6, log of 7 base 7, log of 100 base 100, what do you notice about these two numbers? They're the same. Do you realize if you were to rewrite that, 5, so if I said what is this equal to, what's this equal to, what's this equal to, what's this equal to? 5 to what power is 5? 1. 6 to what power is 6? 1. 7 to what power is 7? 1. So when these two numbers are the same, the answer is going to be 1. Now, do you know where the 1 comes from? It's the exponent of that number. So if I gave you this problem, log of 5 base 5, and it's 5 squared, what do you think the answer is going to be?
2.
It's going to be 2. And I'm going to prove it to you.
Wait, why is it 2?
Because I'm going to show you the property in a minute. Hold on to that thought. It's at the very bottom of this page. So let's build up to that. All right, so I'm just trying to get you to think. For this problem, if these two are the same, the answer is 1. And so x is 1 for this problem. Whenever these two are the same, the answer is going to be that exponent, which is a 1 there. Now look at this problem 2. So what is this equal to? Let's rewrite it. 8 to what power is equal to 1/8? So what exponent would this be so that you turn this into 1/8?
Would it have to be a negative 1?
Yes, exactly. This would have to be a negative 1. Why?
So that way you can flip it.
Because you can flip it. So that's what you need to think. So this answer is negative 1. Very good. Now, does anyone have a calculator? Can you type this in your calculator? The log of 1/8 base 8. I'm going to show you right now on this calculator. How do you do this?
Got negative 1.
Okay, so how do you type it in? You're going to hit Control log, this 10 to the x power, and that's going to show on your screen. The base is what? 8. Type an 8 there, and you're going to type in a 1/8. And then hit enter, and you get negative 1. Now, see this calculator that's in front? This is like the Cadillac of all calculators. This calculator gives you the opportunity to type it in as you see it. But if you are not blessed to have that type of calculator at home, how many of you have the Inspire at home? No one.
No calculator.
So, how many are lucky to have an 83 or an 84? Okay, a few of you. And if you don't even have that opportunity to have this, you have the Texas Instrument TI 30XS, whatever, the ones that are on the wall back there.
Got a cell
So,
phone.
this is more advanced than those calculators, and this calculator can't do what the Inspire did. What you have to do is called the change of base formula. I'm gonna show you how to do it on the cheapy calculators, I call them cheapy. So, the change of base formula looks like this. Change of base formula. You are going to do the log of this number, 1/8, divided by the log of this base. So you take the log of this number divided by the log of 8. We call that the change of base formula. So if I show you, I'm just going to show you log of 1/8. Let me clear it. I did it last hour. Log of 1/8, 1 divided by 8. And I have to put that in parentheses. And I hit divide. And then I'm going to type in log of 8. Guess what answer I'm going to get?
-1.
-1. Now, I wish that this calculator could type it in just like that, but it can't. It doesn't. So you're going to want to make sure, while you're in this class, you have a Cadillac in front of you. But when you go home, I don't know what's in front of you.
A Honda.
Honda. A Honda. All right, so problem number 3. There's 3 ways I want you to do this problem. The first way is with your brain. That's the most important way. How do you rewrite this? 2 to what power is equal to 32? And you said it, 5. So if I raise 2 to the 5th power, I get 32, correct?
Yep.
Now, how do you do it on the Inspire? Control log.
Can't see it.
Can't see it?
Yeah, there
Just like that. And guess what we got? 5. Now, what if we don't have the Inspire? What are you gonna type? What do you type?
32.
Log of 32. Then what?
And then log of 2.
Divided by
Log of 2.
log of 2. And what answer should you get?
5.
5. Okay? Now, these next 3 problems are review. It's just a review of the properties of exponents. This is prior knowledge you should have. If bases are the same, and you are, what's that little dot mean? Multiplying. If bases are the same, and you're multiplying, what do? You keep the base the
Same.
and
And
add the exponents. Good. So if I gave you x squared times x cubed, how would you do this one?
Just x to the 5th.
X to the 5th, and you simply added the exponents, okay? How about this one? If you have a power to a power, what do you do with these 2 exponents?
You
You
multiply.
multiply them. So if I gave you x squared cubed, what is this?
X to the 6th.
X to the 6th. And a quotient, what do you do on
You
that?
subtract.
You subtract. You guys know this, right?
Yeah.
All right, so now, here's your first, this is a new property. It's called the product property of logs. If you have a product, and this is just m times n, how did they break this up? What did they do? Check out the B. It shows up here and here.
Oh, they distributed it.
Okay, what they did, okay,
And
you
then
can
they
say
changed the plus to
distributed.
a-
But what do you notice about this and that sign?
We changed the multiplication to
Yeah.
L.
So it's broken up as, if it's a product, it's a sum.
It's some bull.
So now watch this one. How do you think you're gonna break, this is a product. This is gonna be written as the log of 2, base 2, you're gonna put plus the log of x base 2 plus the log of y base 2.
That's too much. Oh.
Okay, you'll get the habit. So if you see a product, you're gonna break it up into pluses. Okay, with that said, flip to number 8. Can you go the other direction? If you see a plus sign with two bases that are the same, how would you express this as a single log? You're gonna go the other way.
Isn't it like
So it'd be a log.
3,
Log base 3 is correct.
parentheses 2 times 8?
8 times.
Very good. 8 times 2 or 2 times 8. Well, can you do 8 times 2? What is 8 times 2? You
16.
got it. Good job. So, can you remember, a product is plus. But what has to be the same?
The base.
The bases. The bases. Now, try number 11 on your own. Can you express that? I want you to stretch this out. How would you write this one? Anyone?
Log of 36 with the base of 6 plus log of A base 6 plus the log of C base 6.
Beautiful.
That's the
Perfect.
answer?
That's it.
Oh.
That's it. Now, there is some simplification stuff you can do, but we're not into that. You could rewrite this as a 2. Because the log of 36 base 6 is 2. But we're not there, we're just expanding, we're practicing. All right, go back to the front page. So does everyone think they understand the product rule for logs?
Wait, could you go back to 11
11, yep,
for 2 seconds?
yep. Travis is this on the screen.
Alright, thank you.
Yeah.
Okay,
Alright,
are you good?
yeah.
All right, now, so does everyone, thumbs up if you have the product rule? What is it? A bunch of pluses, right? All right, now we have this quotient rule. Check this out. This is a fraction. We call it the quotient property. What did they do now? Did they add? No, they subtracted. But check this out. What they did was they have a product on top, and then they have a division, quotient. So, does anyone think they could figure out this one, using pluses and minuses?
Log
Log of
2x.
2, okay, we could write 2x. Go on, keep going.
Plus log of y.
Plus,
Minus.
minus, remember minus for division. Log of y base 2. Now, is there something that we can do with this? Yes, that's a product. So you can write this as the log of 2 base 2.
That's the log of x base 2 minus the log of y base
You got it.
I have some,
So did you need to write this step? If it helps you, fine. If you could go right from here to here, great. All right, so I want you to do 9 and 12. Flip it over. 9 and 12. Number 9. How are you going to do this one? the log of 12 minus the log of 4, and both of them are base 3. So how can I condense this?
Log 3.
Where did 3 come from? Oh, so log, okay, because the answer is 3. Oops. When you said it's log base 3, okay, now is there any
Wait,
simplification?
where'd you get 12 over 4 from?
4 goes into 12 3 times.
Wait, you're putting it together?
It's a
or-
subtraction problem, so we divide. If it's a product, if it's a plus sign, we multiply.
Oh, you're putting it together. That's-
Yes,
I-
we are writing it as a single log. So if the bases are the same and you're subtracting, you are dividing. What is 12 divided by 4? And if someone said simplify this problem, what answer would you put down? No?
One.
What's the answer?
1.
What is the log of 3 base 3?
1.
1. So believe it or not, all of this is really equal to 1. But in the directions, it just says, write each expression as a single log. Then simplify if possible. So this is the first step. That's writing it as a single log. And then the second part, which says to simplify it, what is the log of 3 base 3?
1.
1. So there's 2 answers here. Okay, can you take number 12 and rewrite that? This is a quotient, so how are we going to separate them?
Log of x to the base
Log of x base what?
4
4 minus
log of 64.
log of 64 base 4. Now, that is expanding it. Now, can anyone simplify one of these two?
Would it be 64 divided by 4? Or-
Yeah, if you did log of 64 divided by the log of 4, you could do that on a calculator. Can anyone think, using their brain, what that equals? What is it? No? So, 4, I heard it. Who said it? Lois? 3. She's right. Lois, how'd you get this to equal 3?
Because it would be 4 to the x power, and it would equal to 64, and 4 to the third power is 64.
Perfect. So this really is another name for 3.
Would it still be subtracting 3?
Yep, just like that. Yep. Okay, now go back to the front. Last property. This is called the power property. Now, I'm gonna tell you what you're gonna do, and someone's gonna say, well, why? And then I'm gonna show you why. See this, it says the log of m to the p power base b. What did they do? What did they do? The log of m stayed there, the log of b, but what happened to this p? The p came in front. That's what the property tells you to do. So the power, if you see a power here, it comes in front. And someone's gonna say, why? Right? So
Why?
this is equal to 3 times the log. See this 3? It's gonna come in front. The log of a base b. Now I'm gonna prove why it's that. Here's why. What's another name for a cubed? Isn't it a times a times a? Yes or no?
Yeah.
Isn't a to the third power a?
Yes.
Okay, now what property did you learn? If you're multiplying, what do you do with these?
You add
You add them. So tell me if you agree with this. Do you agree with what I did?
What?
Yeah.
So,
Okay,
It's more than
a
yeah.
to the third is another name for a times a times a, right? This is repeated multiplication. Well, if it's a product, what do? We add them. In multiplication, how can you use multiplication to change this problem? How many of these log A base B do you have? You have 3 log of A base B. Does that make sense?
Yes.
So what happened with this 3?
It's just public.
You just brought it in front. Does that make sense? So a product rule, or power rule, you bring that in front, and let's see if you can do 10. So can you go the other way? If you see a number in front, it's called a coefficient. What do you do with this? You're gonna back it up. Back that up, and back that up. So how can you condense this with the 3? The 3 belongs to the R, and the 5 belongs to the N. So step 1, I'm gonna write the log of R what?
3.
Cubed, base 2, plus the log of N to what power? 5, base 2. Now, is there another step
Can
we
I ask you a
can?
question?
Yes,
Where'd you get the R cubed from?
this, a number in front, is the power here.
Oh, I keep forgetting that you're like putting it back to like.
You're going back.
Yes.
Write each expression as a single log. You have to go from expanding to condensing, condensing to expanding. You have to be able to go both ways. So, it says write it as a single log. So we're trying to condense this into one single log. Now, can we condense more? Right now, we have 2 logs. And what is this, what sign is this? It's adding. And are the bases the same?
Yes.
So how do we write this, how do we put these together?
Log
Log.
R cubed N to the 5th to the base.
Perfect. All right, and let's see if you can go the other way on number 13. What is this power? We want to expand this one. So, what are we going to do? You could distribute. How would you distribute this? Does everyone agree with that? Okay, then what would you do?
Wait, what did you distribute, the 3?
This 3. This is the power. Remember, we talked about the exponent rule, power to power?
Yeah, you multiply it.
You distribute them. 3, you have to give these to both of these. So can anyone do this one? Log. So what did I first do? I applied the product rule. Is there a better answer?
Log.
Yeah, you can take this, you can make that 9, right? Or no? Holy.
This 3 goes in front, so 3 log of 3 base 7 plus 3 log of x base 3. Now, there was another way you could have written this problem. Does anyone know a different way you could have done this? I heard it right here. Who said it? Someone said put the 3.
In the front.
Who said it?
Yes, it goes.
Oh. Mr. Duke said it. Put this 3 in front, and you could write, everybody look at this. What did I do? I brought the 3, or he brought the 3 in front, and made it a product rule, which is the same as the distributive property this means the same thing. Okay, how much more time do we have?
Couple, 2 minutes.
2 minutes, okay. I showed you this change of base formula. I want you to flip. Can you, on your calculator, do 14 for me? Not done. If I tried to rewrite this, 7 to what power is 56?
8.
I can't, 7 to the 8th power is 56.
Never mind, never mind. 5 minutes.
Okay, so if you try to rewrite this one, you're not gonna get the answer. So you need a calculator. How do you type this in your calculator, ladies and gentlemen?
Log.
Well, it depends on which calculator you have. So, you're gonna type in, if you have the Inspire, control log, and just do base 7 and 56. And your answer is 2.07.
Hey, what number is that?
Number 14. Okay, so for homework, I want you to finish 15. Try to do this story problem and do the back. It's not hard. There's only 11 problems.
Yeah.